So I hope you're able to see my LeetCode screen. Yesterday today we're going to continue from where we left off yesterday. I shared this solution with you guys to explore yourself. I had a little bit of confusion how it's working. Then today I got some time to review this and go step by step so I can explain better today. This suffix part can be a little bit tricky, but we'll give it a go. Okay. First, let's review this question. What this question was. A quick recap. So let me reset the code. Confirm. So the question states that given an integer array, nums, return an array answer such that answer of I is equal to the product of all elements of nums except nums of I. You're given an array nums 1, 2, 3, 4. Okay. And we need to return an array named answer such that answer of I, each element of the new array answer of I0, answer of I1, and so on until the end. Then these right here, these values are what? Are equal to the product of all elements of nums, are equal to the product of all elements of nums except the nums of I. So for example, this is your I, except this element, I want to take product of all the elements and store it here at I of 0, because here I'm dealing with I of 0. And then as I keep moving forward, I keep excluding the element that my iterator lands at and take product of all other elements and store it in the answer array. So the approach we decided to take for this question was to compute prefixes and suffixes of the given array nums. So this is your nums array. You would want to create prefixes this is your array nums. If your I is landing here, the number before that, all the numbers before that, and all the numbers after that, you can consider them as prefixes and suffixes. What this will allow you to do is to segment the array into two sections, and the kind of section that can increase and decrease with time. Because as my I moves forward to the next element and the next element, my prefix window will increase and my suffix window will decrease. So initially, if I have prefixes 1, 2, 3, 4, if my I is here, I don't have any prefix. I only have a suffix. I have all the elements available after I. So those elements, we can call them suffix. Okay. If I move to the next element, now I have one prefix and two suffixes available. So initially we had 3 suffixes and they got reduced to 2. And initially I had 0 prefixes and it got increased to 1. So if I keep continuing this way all the way until the end, can I say as my prefix increases, my suffix decreases. They're inversely proportional to each other. Can I say that? Yes. Because this is inversely proportional to each other, these two quantities. This is the behavior we observed. Can I say as my suffix increases, my prefix decreases. Can I say that as well? In this array right here, 1, 2, 3, 4, as my suffix increases, my prefix decreases. Can I say that? If I'm moving I in the opposite direction. Okay? Yes, that's true. So what if I can take all the products of prefixes at once, all the products, and I can take all the products of suffixes prefix by moving my I in the positive direction and suffixes moving I in the negative direction. I can compute all the product of the elements, and then I can establish this, and then I can multiply these suffixes and prefixes, keeping in mind that the higher number of prefix should multiply with the lower number of suffix. You should maintain this relation while multiplying this. That will allow me to compute the products without writing nested loops. I can run a separate loop for prefix, and I can run a separate loop for suffix. If that's all makes sense to you, I have an example for you that I tried, and I implemented nested loops. Only 19 cases were accepted out of 24, and then the time limit exceeded. If you can look at this solution right here, no, this is not the one. Is this the one? Yes, this is the one. Yep, it's fine. If you can look at the solution right here, what I'm doing here is I'm running the iterator I over the entire length of my nums array. That is my input. Okay. And while I'm doing that, I have created two functions. One is for computing the prefix and one is for computing the suffix. This is the function that computes the prefix, and this is the function that computes the suffix. How am I making use of these two functions? Is that I am taking subarrays of my nums array. So if my nums array is 1, 2, 3, 4, and I want to compute prefix, if my I lands here, can I say the subarray, or easier example, if my I lands here and want to find the suffix, can I say my prefix is from 0th index to I, excluding I, of course. Correct, yes. And my suffix array is from I to the length of array. Can I say that? Yes. So I've established a relationship between I and the 0, resulting into the prefix I, and to the length of the array, I'm getting the suffix. Got it? Okay. So if you look at this function right here, I'm slicing my array from 0 to I. I'm using this function. How this function works is it takes your array as an input and then slices it based upon the range that you give it. From 0 to I, it will segment it and call it a prefix. And pass that segment of the nums array into the prefix function. It will repeat the same for suffix, except that it will take your indices from I plus 1 to the nums dot length. I don't want to include this. So in a case where I have my 1, 2, 3, 4, in the case where I have my I still at 2, can I say if I want to take 3 and 4 as suffix, I need to include I plus 1. and I plus 2. But there's another name for I plus 2. The other name for I plus 2 is the length of array minus 1. This will give me the last index. So if I'm using a function like range, if I'm giving it the last index and the I plus 1, I'm getting the suffix, which is 3 and 4. As I keep looping, my I keeps increasing and my indices change. I'm getting the changing subarrays along the way. And I'm feeding those subarrays into these functions. And what are these functions doing? Anytime a prefix has been sliced out of nums, it gets fed into prefix function, and the suffix gets fed into suffix function, the suffix subarray. And how these functions work is that your prefix function it multiplies. Let's say if this is the prefix segment, it multiplies all the elements in this subarray, which is the prefix subarray. Okay. Once let's say in the case of when I have a suffix subarray, it will multiply all of these elements. Okay. In a way where, of course, we're not repeatedly multiplying these numbers over and over again. Once I have multiplied 1 and 2, I can store it in a prefix product, just like here. So if I've already computed 1 multiplied by 2, the next thing I need to multiply is just one more element, which will be 3, and it will still give me p is equal to 6 for this segment right here. Because initially my segment was 1 and 2, and then increased to 3. This was pre-computed, and we multiplied 3 into it. And that's how we got our prefix product. We applied the same rule for suffix product. If it's already been computed, if 2 and 3 as suffix have already been computed, I don't need to reiterate over it. I will just do one more iteration. But here if you pay attention, we are using nested loops, which is making my algorithm O of n squared complexity. How come? Your first loop, you can mark it right here. This is your first loop. So for each I that moves, you're running 2 independent loops. One loop is this, and the other loop is right here. Because for each I that moves, you're computing the prefix and running a loop for prefix and running a loop for suffix. But that does not mean they're nested loops. If you're thinking it's O of n cubed or something like that, no, it's not like that. Actually, you have one for loop, and then underneath that, one for loop is running independently for prefix, one is running for suffix. Okay? Now, if the outer loop is O of n, inner loop is O of n, and this is O of n, because they're not nested. These two are not nested. These two are not nested. So in this case, this is going to run O of n, this is going to run O of n, but each one of them is going to run O of n for these. So my worst time complexity will be O of n squared. Or you can say 2 of 1 because there are 2 O of n's. They're the same level, same scoping. But these two are nested into this, so this will be 2 you can disregard, and it will be O of n squared, worst time complexity. And that is why you have the time limit exceeded for a case scenario where we had something, an array that is as big as this right here. It only passed 19 cases. So there can be intuitive thinking, okay, I want to avoid these nested loops altogether. What am I doing wrong? Or what can I do differently? And let me remove this so it's easy for us to start thinking from scratch. If you have noticed in the 1, 2, 3, and 4, what I'm doing is I'm moving my I and I'm trying to compute prefix and suffix at the same time, right? Because my idea of computing the products is that if a prefix is generated, only then as a result my suffix is being generated, right? But that's like a very obvious observation. If you want to go a little bit deeper, you notice the pattern that if you get rid of these terminologies, prefix and suffix, what are you seeing is that there are just values that are multiplying. They're numerical values that are multiplying in a pattern where if on the one side, the numbers are decreasing, on the other side, the numbers are increasing. If one side number is decreasing, on the other side, it's increasing. So why not? Anyways, we're going to multiply all of these elements of this array. Why not just compute all the prefixes and all the suffixes, right? And then simply multiply the elements where this one, we make sure this one, when we have a prefix 1, it gets multiplied with the product of 4 and 3. If I calculated this suffix 4 times 3, I put in an array 12, okay? If I put my suffix here, and if I put my prefix in a separate array as 1, I need to make sure that when I multiply suffix with prefix, if I run a loop, or if I run a separate loop, or come up with a multiplication method, I need to make sure this 1 gets multiplied by 12, and then this 1 multiplied by 2 gets multiplied by the suffix 4, right? And that is the only way I can make sure that I get the same result, because now I've determined a pattern. So 12 times 1 is 12, 4 times 2 is 8. Do these two numbers look familiar to you? 12 and 8, right? Similarly, we can compute these two as well. Granted, if we have computed the entirety of the prefix and the entirety of the suffix. But there's a smarter way to do things. Not just compute entire suffix separately, store it somewhere, and then, multiply them. You know the pattern that increasing suffix multiplies with the decreasing prefix. And there's one more thing that we just ignored, and it's an important part of it, that the size of this array right here is going to be equal to size of this array. Because all we are doing is increasing the values right here. Or if these are negative, we're decreasing the values, because in negative numbers, negative integers, the higher you go, the smaller your number is considered to be, right? So that's why I say that when you're multiplying, either you're increasing this number or decreasing. Don't think I'm talking about division. No, I'm talking about multiplication. But when in negatives, when we go for a higher number, we're saying the number is decreasing. So negative 24 is not greater than negative 23. It's actually smaller than 23. Okay? So we're not increasing the length of the array. The length of this array is equal to the length of this array. This is the resulting array, and this is the input array. So the length is same. All we're doing is getting the products. Okay? So that means that we can define an array answer, which is what they have required, right? And we are taking the products, and we can make sure that within the same limited space, if I'm computing suffix, I'm computing prefix, I'm going to eventually, I'll have an opportunity to multiply prefixes with suffixes. Okay? Now, what I meant by that is, okay, a little bit deeper thought, is that let's say, what's the logic behind that? What's the insight behind that is, let's say you have a box, and inside that box there are multiple boxes. Okay. And inside that box, you have access. Let's say you have put an apple here, an orange, and let's say fruit 1, fruit 2, fruit 3, fruit 4, fruit 5. if you have access and complete control over these boxes, where you can rearrange the order and where you can relocate these fruits into different boxes, can you assume that you will have opportunity to put orange here and apple here, and eventually apple and orange can meet? Similarly, in an array, you can determine that your prefixes and suffixes can establish a relation where they, if multiply, will give me the same answer if I would have done it in the nested loop. I guess we have a question. What would be the other question? Maha, could you unmute and explain what you meant by this question?
Basically, yesterday I solved this question, and if we are, I want to know what the other question we are going to solve. If we are going to solve only this question, then I will skip the lecture and I will do something else.
Yeah, that's fine. Actually, I'm trying to focus on this one. If you can get done earlier, then fine. If not, but from my end, this is the only question I'm going to present.
All right.
I'll try to wrap this up. Yeah.
Thank you.
Yeah, no problem. All right. So let's move back to the. Okay, I hope you guys understood what I'm trying to do here. Okay, I'll simply move my code that I've submitted just to save time so that if someone else wants to present a question or if we want to discuss something else, we can. Right now it's 8:23 p.m. on my side. We have only 7 minutes left, so I'll try to wrap it up in 7 minutes. Okay. So I'll just simply go to my submissions and move my code back here. I had posted this solution into this Slack channel as well. Okay. Okay. So this is the solution where I'm computing the prefixes separately, and then I'm computing the suffixes separately, but I'm doing something smart here. What I'm doing here is that the prefixes that I've already computed upon, right? For example, it's 1, 1, 2, 6 is the array of my prefix. What I do is every time I compute a suffix by going in the reverse direction of my array 1, 2, 3, 4, when I find the suffix, let's say my suffix is 4, I just multiply it to my prefix to compute the answer, right? Because ultimately we need to multiply prefixes with suffixes. That's what we need to do. So instead of storing your suffix in a separate array, you can modify the same prefix array, which is right here. And you don't even need to create a separate prefix array. You can just create an array with answer, integer type answer, and store your prefixes here. And when you have stored your prefixes here, as you keep computing the suffix, you can multiply the suffix with all the prefixes, right? And this answer array will turn into your answer array. Finally, you can return this. Okay, let's go step by step, and then I'll tell you what is the time complexity of this solution. Okay. So first of all, what I'm determining is the length of the array. Like I said, the length of your input is going to be length of your output. That's not going to change, right? So first I compute the length, and then I use the same integer, the length that I've computed into this, initializing this new array. So what this is telling you is the answer array that you are initiating, that has to be the size of n, and the size of n is basically the size of the input array. Okay, so your answer array is also the size of the input array. Next, answer of 0 equal to 1. There's a technicality here. 1, 2, 3, 4. Okay, 1, 2, 3, 4. Now, when I'm computing a prefix, let's now talk about prefix, okay? Right now, the goal is to only compute prefix. How do we compute prefix? First of all, my I is here. This is your entire suffix, but we're going to disregard it right now, can you take this as a prefix? No, you cannot, because the element that your eye is going to land on, that's the element you cannot consider, right? That's the whole point. So since we're computing prefix, we'll consider the first prefix as 1, because whatever we multiply with 1, that's not going to change the answer, right? Whether we multiply 1,000 by 1 or 2,000 or just multiply 1 by 1. But if you make it 0, then your entire product can turn into 0, and that's not what we want. In products, we initiate our integers that we are going to multiply by to get some answer. We always initialize it with 1, okay? All right, so answer of 0, the first element of this answer array is going to be 1, okay? So now, if this is my answer array, this is my answer array, my first element is at 0 is 1, okay? Now, this loop right here starts from the next element, right? We cannot include this. So now I have to move my window. My prefix window will increase now. My prefix window will increase. Suffix will decrease. So this is my prefix window and this is my suffix. But now my eye has moved to which element? It has moved to the second element, right? Even though the index is 1. Now, can I include this? No, I cannot include this, right? But since I'm computing prefix, like we discussed, all the numbers in prefix have also to be multiplied. 2 multiplied by 1. This has to take place, right? But here, this is my prefix, this is my answer array. I'm going to exclude 2, and let me write this clearly so it's not confusing. Right now, this is the only element in the answer, which is my prefix. Okay? How will I compute the next prefix? This is my 1, 2, 3, 4 is my nums. Okay? My I has arrived here. This is my prefix. I multiply this by 1, okay? Because this is my current computed prefix, and store the result. So this is my second prefix number. Now I move my I further, right? 2 has become free. I'll take 2 and multiply it by 1. The second element of prefix, the second product. Now my answer is 2. Now my I will move to 4. 3 has become free. 3 has become free. Okay. 3 has become free. And now multiply 3 by 2. Can I put 4 in? No, of course I can't, because there's no element after 4. And this is the maximum prefix window that I could compute. Now we will compute the suffixes. This is my, inside the answer array, I have all the prefixes. Okay. Now the suffix is a little bit tricky. I have made mistakes trying to practice it, but I'll give it a go. I need you guys to pay attention to this one. Catch me making mistakes, if you could, please. And again, this is my nums array. As I say, my suffix should always initiate from the right side. Just like we did for prefix, we increase our window. For suffix, we have to increase our window as well, right? And that is the only way we can multiply it, because whenever our window increases, that's the number that we include. So we want to include the minimum number. Initially, the window will be small, so that way we can make sure the small number is being multiplied with the larger product of prefix. So that's how we're going to do this, right? So that's why we're going the opposite direction. For increased window of prefix, for increased window of prefix, we're using decreased window of suffix. We're multiplying that, okay? So if you can, I think I skipped this one. Answer of I, basically, when your index is at 1, right here, what you're doing is you're taking the previous element, which is, if this is your I, this is I minus 1 of answer I, right? And you're taking this and you're multiplying it with the nums of I. So nums of I is 1, right? So you're multiplying this one, right, with this one. So this is all it means. Nums of I minus 1, your I is here, I minus 1 is this, and you're multiplying this. This is a simple multiplication I did. You guys can spend some time on it, understand how it's working. It's not that intuitive at first, but because you're taking two different arrays, you're multiplying the previous indices because you have to take a product and then you're storing at the same index of the answer file. It's takes a while to understand it. Okay, now we're going to come to the suffix. Okay, on the reverse pass, we're going to opposite direction. All right. So now, like I said, I don't need to store another one for suffix. Suffix, I can just simply multiply with all the prefixes and then I have the answer. How we're computing suffixes, we are setting our iterator I to n minus 1. What is n? N is the length of array. Okay. So if this is my array, I am setting my I here. And then as long as my I is greater than 0, right? 1, 2, 3. These are the indices. Right now, my I is at third index. So as long as my I is greater than or equal to 0, right now, I is greater than 0, it's at 3, it's greater than 0, and now it's right at equal to 0. Until then, I can run my loop. And meanwhile, what I do is I'm taking the answer of I, okay? This is my answer, right? Okay. What is the value of I right here? The value of I right here at the first iteration is 3. Okay, and this is my nums array. 1, 2, 3, 4. At the first iteration, what is the value of I? I is equal to 3 because we're going in the reverse direction, right? So when I'm going reverse, I'm taking the suffix, right? I'm taking the suffix and multiplying it to the nums of I. Okay, so I'm taking the suffix, multiplying with this one, and then I'm going to go this is my new answer array. Okay. So I'm multiplying this and I'm storing it here. 4 times 6 is 24, right? This is a prefix and my suffix will increase. Now 4 times 3 is 12. Hold on, let me look at it. This is where I'm getting a little bit confused how these are actually getting multiplied. While implementing it is pretty easy, but now it's getting a little bit difficult. All right, so the first time it's going to be 4 times 1. Okay. Let's reverse this array. I think that's going to make more sense. 6, 6, 2, 6, 2, 1, 1. Okay, so my answer of I, this is where I'm storing my answer. Suffix product initially, this is going to be 1. Okay, and as I'm taking I is equal to 3. So my initial array was 1, 1, 2, 6. Okay. So for 1, 1, 2, 6, 0, 1, 2, 3. I'm multiplying this one. I'm multiplying this one at the third index and multiplying it by 1. Once I multiply with 1, I store it in terms of I. Then I come again and I multiply 1 with answer of I, which is this right here. Can can someone help me out here? How these are going to get multiplied? This order is not making sense to me at all. But if I do it in a brute force way, I think 1, 2, 3, 4. This is my first array. Okay. I'll compute all the prefixes and suffixes. So in that case, my prefix is going to be this is going to be okay. I'll do it brute force, so that's fine. So for the initial prefix, I'm excluding this one, right? So right now I don't have prefix, I'll take 1. And I'll compute all these as suffix, which is going to be 24. Okay. Next, my prefix moves here. And my prefix moves here. And then so three, four. Prefix, right now your prefix is 1, your suffix is 24. And then when your prefix moves here, my prefix is 1 and suffix is 12. It moves here, my prefix is 2 and your suffix is 4. Okay. And then moves here, your prefix is 6 and your suffix is 1. Okay. All right. So if you remember the array that I generated for the prefix, it was 1, 1, 2, 6. And now we need to generate these suffixes. So initially my suffix is 24. Then my suffix reduced to 12. And then my suffix reduced to 4. And then my suffix reduced to none, which is 1. If I multiply in this order, where I'm multiplying 24 by 1, 12 by 1, 4 by 2, 6 by 1, the array I get is the array I get is the array I get is 24, 12, 4 times 2 is 8, and 6 times 1 is 6. So this is our answer. 24, 12, 8, 6. So once you have computed the prefix array right here, you have to make sure while you're multiplying with that array, it has to be in this order. 1, 1, 2, 6. Okay. And this order, then you generate the largest suffix. Okay. So what do we need to do to generate the largest suffix? For that, we need to, we can either start from here. Yes, we can start from here. Instead of computing the prefixes, now we compute the suffixes. So you take the largest suffix, you multiply it with the first, and then you take the smaller one and the smaller one and you keep multiplying here, right? So initially it's 2 times 3 times 4, it's 24. 24 times 1 is 24. And then you take, and let me remove this code so these drawings become more clear. Okay. Instead of computing the prefix, now think about computing the suffixes. What is the suffix right now? 4 times 3 times 2, 12. Sorry, 24, right? 24 multiplied by the prefix, it's what, 24. Now reduce 24 to 12. Now just multiply these and multiply 12 by 1. You get 12. Then reduce it further, multiply 4 by 2, 8, right? Reduce it further, you get 1 and multiply by 6. Okay. So I've generated 24, 12, and 24, 12, 24, 12, 4, and 1. I've generated these, right? So what if you can generate 1 first, and 24 and 4 second, 12 third, and 24 last, and then multiply it the way we have multiplied it earlier. Then you get the answer. So now you have a direct relationship. 24 by 1, 12 by 1, 4 by 2, and 1 by 6. Now let's see how they're doing in that in code. I hope you guys understood the approach that I've taken here, multiplying the increasing suffix with the increasing suffix with the decreasing prefix, and that should give us the answer, and that applies to all the examples. And let's go back to the code. I'll give it a final shot and then I'll close down. Okay. So initially we take suffix part as 1. Okay. Now we're trying to go in a manner where we are multiplying by 1126, 1126. So we're doing 6 to 1, 1. In that case, if you go in the opposite direction of this, 1, 2, 3, 4, what we're doing is we're storing the answer of I, which is the third index, we're storing the suffix product, 1. So we're multiplying 6 by 1, and then we're multiplying 2 by 4, and then multiplying 1 by 12. Okay. Answer of I stores multiply by suffix product multiply by nums of I. Your nums of I is 1, 2, 3, 4. Your suffix product, and the third answer is third is this. So you multiply third by the first one. Yeah, sorry, I'm unable to depict this, but I hope I was able to convey how this works. But basically, you're multiplying them in the opposite direction.
Can you please allow annotation? We can break
Sure.
it down step by step.
Sure, please.
Maybe
just a second. Enable notation others. Yeah, you can go ahead and
yeah. Basically, you are reversing. Basically, you can see we have this prefix array, right? And why you are reversing this? But in code, if you see you didn't reverse it, right? Suffix array. I think that is creating a confusion here.
right.
Okay, let's go with this prefix array where we have 1, 1, and 2, and 6. And we are starting with answer of I. And we have, for now, we have I is equal to 3, right? And at answer of I, which is this answer, which is this 3, we have 6, right? 6 into 1 will be 6, okay? And suffix of product which is equal to 6, and 6 into nums of I. Nums of I, where we have nums of I, it is we are currently here, and nums of I is 4. right? At this stage, we are computing suffix of product is equal to suffix of product we have currently is 6, and 6 into 4, which will be 24.
Correct. Yes.
Okay. And now suffix product will be 24. Okay. Next we have I will be 2, right? And
Right.
uh, we have answer of I, which is this. Okay, we have answer of I is equal to which will be this one. We are at 2 currently, and it if we multiply it with suffix, I don't know it. I think it's a confusing one as well.
We are updating the suffix product and restoring it in the answer file.
Sir, I think we can go on Python Twitter. It will be easy to demonstrate it.
Yeah, let me allow you to share your screen and you can go ahead and take control. Hello.
You can, okay. Let me open this question.
Actually, you can go ahead and share your screen.
ओके तो मैं ये कहना चाहूँगा कि हमारे साथ सर जुबैर सफ़र भी हमारे ज्वाइन किए हैं, तो अगर किसी का कोई क्वेश्चन है तो काइंडली पूछ सकते हैं। अस्सलाम वालेकुम सर, कैसे हैं आप?
वालेकुम सलाम। अल्लाह का शुक्र, आप कैसे हैं?
मैं ठीक हूँ। ओके, अगर किसी का कोई क्वेश्चन है तो काइंडली पूछ सकता है, अदरवाइज से जो सर का मीटिंग कर रहे थे अपनी स्क्रीन शेयर करके कर सकते।
Sir, can you please share code here in chat? Let me
Yeah,
first implement on
sure.
Python Tutor.
Actually, somewhere like deep down in my brain, like I understand how it's working, but when I'm trying to explain it, I'm getting like confused, getting lost in loops. So I think I'll need to break down this suffix multiplication into multiple steps where each step is clearly showing when suffix product is getting updated, when is it getting stored in the answer file, and in which order by which element it's getting multiplied. Because once your suffix product updates, increases, it multiply with the next element of your prefix and it keeps updating at the same time. Excuse me. So there are multiple things happening in only 2 lines of code. That's why it's this make us go and run. But I think the concept is clear. It can be implemented in other ways, which is way easier. My mistake here was once I had written down all the steps that are required for this, I fed this to GPT to write me a clean code of my original version. And that's where we have this without understanding. Due to lack of time, I want to do more questions, but I think it's better to write the code yourself. And this is a mistake that I'm going to learn from is that even if it's one question, make sure you do it yourself, all the steps, and make sure you understand each step. If you don't, then you're gonna have problems, just like I've been having since last 2 days. Oh,
I'm sorry, sir. At my side, internet is slow, so the website is still on
it's
loading.
okay. Do one thing. You're in the channel, in the Slack channel, right?
Okay.
Yeah.
Sir, if you can share screen, just convert this code into Python and go on Python Tutor. We have 10 minutes left. we can do that. You can share screen because at my side it is still loading.
That's not. Okay, what do I do here?
Select Java. Right here. Start coding online. Yes. And edit code. Yes.
Right here?
Right. Yes. Select all and replace your code here. And no, put a example right after the code. Like l- we have on LeetCode 1, 2, 3, 4 nums of array.
Sorry, which one are you referring to?
Uh, Please go back to question and description of the question and select this nums array. Right, example one, nums of 1, 2, 3, 4, and yes, press enter right after the code. Right after the code. Yes. Please call the function which is product except self and pass that array into the function as a parameter.
Okay. Okay, so I click the
Below
right.
nums, below nums, yes, nums of below the array, yes, yes.
How will it understand it outside of the class? I don't think it's going to understand it. This has to be initiated.
Yes, maybe
No,
inside the
for
class.
sure it has to be. And also, like, it's outside of the class. What we can do is we can write a main function here. Okay, we can write a public int public void main function.
Hello, sir. Can I explain in Java?
Yes. And inside the main function, we can call this, right? And we can do something like this, right? And name it nums of length 1, 2, 3, or 4. And then we can actually do like this 1, 2, 3, 4. And product of self, we can call this and pass nums in there. And
And now click on visualize. In Python, we just paste function here and the example it gets visualized. I don't have idea in Java. Please click on visualize execution. Yes, we have some errors. Sir, I will, uh, if you want, I can present it tomorrow. I will convert this code into Python and then we will visualize it in just 5 to 6 minutes. Sure?
yeah, sure, we can do that. Yeah,
Thank you.
Sir, can I explain in 4 minutes?
if you can, why not?
Okay, so I am sharing my screen.
Yeah, go ahead.
Can you see my screen?
Not yet.
Okay, I have shared. Now, can you see?
Hmm.
Can
Yeah.
you see my screen?
Yeah.
So, sir, first of all, we are computing just prefix. I am discussing at Slack. So, computation of prefix is easy. Uh, we have original array like I am sharing. I am writing it 1, 2, 3, 4. First of all, we will compute our prefix. For computation of prefix, we take the first element as 1, and the next element we will skip and take it as 1. So this is we skip 2, and its previous element is 1. So previous element is already 1, so this is 1. So when we come at index 3, so we multiply the previous ones, so it will be 2. And when we move at the index 3, uh, we skip it and then multiply the previous ones. This will be 6. Is this clear?
Yeah.
Okay. After that, we have one variable. We can name it suffix, and we will assign its value to 1. So we can assign this as answer array. So first we have two arrays. This is the ori- original, and this is answer. So for now we have suffix 1. We will start in reverse direction. First we will compute the last element. So we have answer 1. So we
We have
will
only 1 minute left. Please make sure you give
uh,
just one example.
yes, this is answer array. So the last element we will multiply suffix with answer 1. So now we will update our uh, suffix to by multiplying the original array. This will be 4. So when we will come at index n minus 1 minus 1, it we multiply suffix with our answer, it will be 8. So we will update our suffix to again element 3.